Okay, hi everyone. So I'm Liam Crilly, Director of Product Management, NGINX. I look after the roadmap for NGINX Plus and a bunch of other stuff, but that doesn't matter right now because this is 10 tips for deploying NGINX as an API gateway. So I'm guessing that you're here because you're managing APIs, you're deploying APIs, and you're using them inside your organization. But I'm interested in how many people are publishing APIs externally, internet-facing. Okay, and how many are publishing APIs internally for enterprise apps or for internal consumption? A lot more. Okay, so it's true what they say. The API economy is real, and the programmable web is been tracking HTTP APIs since 2005. It's the largest API directory on the web of public internet-facing APIs, and as you can see, the growth of those public-facing APIs shows absolutely no sign of slowing down. We've got about 200 added every month straight for the last 4 or 5 years. But before we go into talking about NGINX as an API gateway, I just want to level set on some definitions in and around this space. So what exactly is an API gateway? An API gateway is exactly like a baseball usher. Now, you might be asking, what the hell do baseball ushers have to do with APIs? But let's look at this from a point of view of what are the top 3 most important things that you want your API gateway to do? What are those top 3 capabilities? And they are this. First and foremost, authentication. Access control, letting the right people through the gates, checking tickets, checking tokens, right? Getting them into your application environment. Secondly, request routing. So taking valid requests and sending them to the correct resource at your backend. And thirdly, traffic flow. Congestion control, rate limiting, connection limiting, making sure that indirectly that the end user experience of the consumers of your API is as good as it can be. But there's one more really important and often overlooked capability of baseball ushers, API gateways. Foul ball. What a hero. Yeah. Exception handling. The API gateway needs to be handling exceptions. You want to be careful about those errors. All right, we'll look at that. So that's API gateway. API management, right? It's the other term that gets thrown around here. And API management is a lot like the box office, the ticket office at your baseball stadium, right? It's got all those back office functions, sets pricing, handles policy, deals with the money, defines the seating policy, allocates resources, puts ushers in the right place, produces reports, all that good stuff. So here we have it, right? API management is about policy, it's about analytics, about monitoring, it's about documentation. The gateway, the authenticator, the request router, a rate limiter, and of course, exception handler. All right, so how many are already using NGINX as an API gateway today? We know Tino is. Now, of the customers that we survey, and we do a survey every year, a brand survey, we're always mentioning it at the conf, 40% or more of our NGINX Plus customers are deploying NGINX as an API gateway amongst other use cases. So it's super popular, and NGINX Plus customers are smart people. The other IT folks are smart people too. These good folks at the other API management vendors know that NGINX is an excellent API gateway. They all use it as the network level proxy in their APIs and their API gateway products. But I'm going to show you how to deploy NGINX as a truly lightweight API gateway without a heavyweight control plane, without additional software components, without databases, without enterprise service buses, just NGINX. So let's go and do that. Let's publish an API and I'll walk you through it. And let's imagine that we are an organization that provides sports results, and that's our API business. Now, you're expecting me probably to switch to some baseball results service from our friends at MLB, but I know absolutely nothing about baseball. So I'm going to show you some Formula One stats. It's more my bag. So we're going to be publishing this, a Formula One results database API, this Ergas developer API, which I found on the programmable web directory. And it's a REST API. You can make calls to look at results, to look at drivers, look at stats, to look at how, why people didn't finish races, all that kind of stuff. And what's better is that it's open source, it's on GitHub, and there's a front-end API and there's a back-end database that's got the stats in it. And even better, it comes with a Docker Compose, so we can actually spin it up offline, and I don't need to pray to the Wi-Fi gods to show you this stuff working. So let's do that. I'll just drop out of here, and I'm going to hit. Typing in a demo is more difficult usually. I'm going to publish this at example.com. So just the top level resource is /API/F1, and default it's just going to give me the stats in JSON format, showing me that there have been 997 Formula One races since 13th of May 1950 at Silverstone. Pretty cool. So that's the pretty version. Most of this stuff is actually going to be running here. So let me just show you that, yep, these are the Docker images we've got running. Let's make that a little bigger. And we'll just hit that ourselves just to make sure it's, I think I did that. I'm clever. Look at that. So same thing, let's make it pretty. There we go. And why don't we see who won that race? All right, 1950, race 1, results, position 1. Let's make it pretty. Look at that, Nino Ferrini, what a legend. Okay, everyone knows Nino Ferrini. So this is the API. Let's do some interesting things with it. Tip 1, organize your config. So this is the traditional install layout for NGINX install, etc. NGINX directory with our primary nginx.conf file sitting there, using the include directive to pull in all of the conf files it finds within the conf.d directory. This is great. Usually we'll drop in here our each website, each web application, so we isolate that config and we can update it without upsetting any of the others. Now, publishing APIs is a little bit different to web applications and websites some of the time. So what we're going to do is introduce some other include files to help maintain that organization order. Right, so in this case, we've got api-gateway.conf, and that's going to be our server. We'll look at that in a moment. And then we're going to pull in include file that defines all of our backends, another include file that defines per file in api-conf.d, each of the APIs that we're publishing. So here we've got f1results.conf, we'll see a lot of that, and maybe someday baseball.conf. I'll move this demo on a notch. All right, tip 2. Use a single client-facing hostname, or as few as possible. So in this example, here's our api-gateway.conf. Our server name is api.example.com, so I'm serving not just f1results.conf, but my baseball results, horse racing results, all of my sports categories are going to be served through api.example.com. This means I've got one TLS configuration to manage. I've got clients who can keep connections open, use keep alive if they're using more than one of my APIs. You get a whole bunch of benefits. And it's very simple and it's very stable. So most of the time when I'm updating, if I'm automating, if I'm pushing new configs and publishing new APIs, I only need to touch what's underneath the api-conf.d directory. My primary server is secure, and I don't have to worry that I'm going to be updating it and breaking things. Tip 3, is to separate definition from policy. So here is the f1results.conf. So I've defined relatively verbosely all of the resources that comprise my F1 results API. Now I don't have to do this. There are simpler versions. I could just have one location block with /API/F1, and that's a prefix match, and everything underneath it I'm going to send to my backend. But there are some reasons why you might not want to do that. In this example, I'm going to be particularly semi-paranoid, and I don't want anything that doesn't look like a request from one of my APIs going to my backends. Right? So it doesn't match one of these, it's not going anywhere. It also helps me with namespace issues. If I have an old version of the F1 results API, or if I'm trying to extend it and I'm deploying some other stuff elsewhere, I want to make sure that I don't step on top of my namespace, and I can be much more granular in my definitions. Also notice that I'm using all three location matching types here. So I'm doing an exact match on /API/F1. So if I hit that, I'm just going to very quickly drop into that location. If I'm, however, looking for results from a particular year, so the 1950 example that we looked at, that's going to be a regex match. And that's I've got a simple regex for matching 4-digit years there. Everything else is a prefix match. That's a default matching. So anything that starts with one of those is going to go into these little location blocks, these one-line location blocks. And all they're doing is rewriting the request to an underscore ergast location with the last parameter, meaning once I find this, I'm immediately going to find a new location block that matches. So I've rewritten the URI to something kind of weird, and that drops me into my policy section, which is where I do the routing, where I do the proxying, and where I do any policy. When I do proxy, I use the original URI. So even though I rewrote it with the rewrite module, when I proxy it, I restore the original URI that was presented to me with the request URI variable. So we send it to the backend. At the same time, we can use these rewrites to group my API definitions neatly together. Another reason why I might want to do this is if I'm building a microservices API. So this suits, this API that we're using. It's one big PHP app. It's a monolith. That's cool. But let's say most of the hits that I get are looking up results. And the core functionality is in the F1 results data. So I'm going to leave that alone. But I want to extend the administration capabilities of this API. I want to be able to do more clever stuff and maybe some big data augmentation around drivers and circuits and constructors and the other top-level resources that exist inside the API. So I'm going to start carving these things out and building them as microservices. So what I want NGINX to do with the API gateway is to do the routing. So I can use the model that I just showed you with the location blocks that I care about. So in this case, I've just shrunk it down to the 4. And now I rewrite the URI to a specific location, which is going to do a proxy pass to the microservice by name. So everything by default, the other thing to pay attention to on NGINX config is that longest location match generally wins. So /API/F1 will only match if it wasn't one of drivers, circuits, constructors. So the longer the match, the more specific wins. And then we drop into one of the location blocks and I proxy pass to the appropriate backend service. So taking this approach of separating the API definition from the policy and the routing means that you get a much easier to maintain config, and it's a model which is more intuitive to use. Tip 5, send appropriate errors. Right, so we already know that exception handling is super important. And what we're going to do with our configuration is build in some general policies for how we're going to handle errors. Now, I've introduced on the right-hand side an additional file, and I'm going to extend my API gateway config a little bit to have a few more directives specifically for handling errors. So first of all, I've got a default location on /, right? And that means if I didn't match any of the resources that I already defined, I'll definitely find this one. And this also saves us from trying to serve files from disk. So this is going to return a 404 because I didn't match anything sensible. What I'm also doing, line 23, is if I get a 404, I could send a 404, that's okay. API clients know what that means. But API clients really ought to know what resources exist. They're not web browsers. Right? Nor do I want to return HTML error pages, which would also be the default, given that NGINX's origins as a web server, that's what it's going to do. So if I send a bad request, I'm going to send a 400 to tell the client you're a bad client. I also might not want to give away the fact that if I'm just scanning resources, that I got a lucky hit. So I can obfuscate if that's helpful for my security posture. Other thing I'm going to do around errors, line 24, is I'm going to intercept errors that were generated by the backend. Right? So if I've got a Java app at the backend and it throws me a 500 with a stack trace, I don't want that reaching my API client, or that's data leakage potential. So I'm going to intercept those errors and send the equivalent NGINX status to the client instead. So NGINX will see the 500 from the backend. Okay, it's 500. I'm going to generate a 500 and send it back. And that means this extra include file I've got for API JSON error.conf has all of the errors I'll send to those clients. Take a quick look at that. So here we are. For every status code that we've got presented, I've got a JSON as opposed to HTML error response, and it's kind of neat and clean, and I just do this once and it's done forever. Let's just show that. So let's say that I happen to be interested in maybe I'm not going to fall off the 3000 fan from back in the day. That's not going to work, right? Bad request. Was I here? Okay. So, not all APIs are JSON REST. How many people are using or have plans to use gRPC in their organization? Is that a thing? It's a little thing. Okay. In that case, of course, you want to send gRPC errors. So there are some default mappings from the gRPC status codes to HTTP status codes, and when we return a gRPC response, you'll notice line 19, they're always a 204. So if we trigger any of the errors, either generated internally by NGINX or captured from responses sent from the backends, then we're going to turn them into proper gRPC compliant errors. Now, coming back to my earlier comment about have a single entry point, this is the exception to that rule, whereby if you're deploying a mixture of both JSON REST and gRPC APIs, if a client sends a bad request, how would you know which format to send? Right. So in that case, tip 5A is have an entry point, have a host name, api.example.com, grpc.example.com, and then your default errors are going to be sensible. Tip 6 is to limit your authentication options. So NGINX and NGINX Plus give you a nice variety of API authentication. We heard earlier today about using OpenID Connect for APIs, but we can also support HTTP Basic, raw JSON Web Tokens, client certificate, X509 client certificate authentication, and plain API keys. But the thing here is just because you can doesn't mean you should. Often there's a temptation to take separate authentication methods for internal consumers for testing and external consumers or partners for production traffic. And the more you do that, the more you're going to end up with hard to diagnose and hard to debug problems, or just bloated config where your policy now needs to be able to differentiate what to do based on the authentication method presented. API keys are also they're kind of old school, they're shared secrets, so they're not super great, but they are kind of still the de facto authentication method. And if you're kind of migrating from another API gateway platform to NGINX, then it can be convenient to build some API key authentication in there. And it's pretty simple to do. But what you don't want to necessarily do is just put all your API keys in a map, and then you've got these shared secrets hanging around in the clear. What we have here is an example where we're going to use the JavaScript module to hash our API keys. So stored in APIKeys.conf, and this could be an easy to generate automated list from another system. We've got SHA-256 hashes for all of the valid API keys that we're allowing. The comments wouldn't normally be in production, but this is so I can remember what the actual API keys are. The map also gives us the advantage that we can take the API key and extract from that a sensible, nicely loggable or proxyable value that we can use for debugging, we can use for logging. A real name, if you like. And so it takes only, or you can do it in one line if you like, of JavaScript to take the HTTP API key variable, so that's the API key request header, and to pass it through a SHA-256 function and spit out base64 encoded version of that. And what we're going to do is when we're presented with an API key like ABCDEF, create the hash on the fly, pass it into the map, and if we get a matching client name out the back of it, API client name being the variable that we'll evaluate to, then we know we're authenticated. The configuration for that inside our results.conf file, and again, this is a nice separation from the definition to the configuration, is that simply put, if the API key request header is empty, send to 401, we're unauthorized, please authenticate. And if API client name, which is what we evaluate the map from, is empty, then you presented one, but it didn't match something that we're expecting. In which case, we're going to send to 403. You might send to 401, but here we can differentiate. We know where we landed. So let's look at that. So if I hit, let's paste it in. Let's have a look at drivers, seeing as we're interested in Nina Farina. Yeah, unauthorized, we didn't send a header. So let's send API key, something bogus. We are forbidden. So that's the simple config we showed you. Now let me swap that out for something that we do know is good. And we get our results. Here are all the A's. So very simple to implement API key authentication, and we can help protect those API keys by hashing them on the NGINX. So tip 8 is to, well, do rate limiting, but know why you're rate limiting. So firstly, I just want to point out that we can have more than one rate limit at a time. So in this example, line 7 shows that we've got a 10 requests per second rate limit based on the client IP address. So we've got some sort of baseline there. But if we provided an API key, then our rate limit is 200 requests a second. So we can treat authenticated users more favorably than unauthenticated users or requests. So in the f1 results.conf file, we simply apply those rate limits where we want them. We might apply it to the entire policy section, or we might apply it to those individual location sections if we want to have different rate limits, either for different microservices or different rate limits for different resources in our API. One other thing to point out on line 20 is that we can control what status code we return. By default, NGINX will return a 503 if we exceed the rate limit. Again, kind of some web server origins of that default. API clients and API gateways typically will be sending a 429, so that's what we've configured to do here. We can set that globally, or we can set it here again in our policy section. And just because we can, let's see what that looks like. So actually, let's do something that's not authenticated. What shall we choose? Circuits. Boo. Actually, tell you what, why don't we look at Alonso? He's an A. There we go. And then let's do that a few times. Okay, we got a couple through, and then we hit a rate limit and exceeded. there's a whole heap of things we can do rate limits with NGINX. We can like delay them until the rate limit can be satisfied, or we can just say, no, you're over the limit. Here's the situation. All right. But this is actually about knowing why you're rate limiting. So we might rate limit because we want to protect the backends because they're fragile and they don't like seeing a whole heap of traffic. They might fall over, so we might want to protect them that way. But we might also want to apply a rate limit to our API gateway because we've got some contract in place with the API consumer, with the API client developer, that you are allowed, at the silver level, 200 requests a second and no more. So there are two distinct use cases for rate limits when it comes to API gateway. And it's important to know which one of those you're using, and at the same time, not allowing your backends to be overloaded as well. So tip 9 is inspect the request method, if you want to. So we can think about REST APIs in terms of their dimensionality. Right? So far, we've been looking at one-dimensional APIs. That is, we just care about the request resource, the URI, the path. Right? And all of our routing, all our policy has been based around that. But REST APIs also have a significant portion of its of semantics around the request body, the request method. So that's post, get, put, patch, delete, all those. And we might want to change our policy or just be super careful about what we allow based on the request method. We'll also see a little bit right at the end that a three-dimensional API means that we might also care in the gateway about the request body as well. So let's go back to the request method. And in particular here, we're looking at the seasons resource. All right, the seasons resource is used for creating, once a year, we'll create a new season, right, in preparation for the next racing season. And there are two things going on in this situation. Line 4, for the catch-all, API F1, basically says, if it's not a get, throw it away. Right. So generally, this is a read-only system. We're looking up results. So the seasons resource is an exception to that because we can have get and we can have post. And we're using the limit except directive to define what's okay. We're also doing something routing-based here with line 10. If we do send a post in, that's okay, but we're actually going to rewrite the request to go to our master DB, master database location, because that's a write, and we might have a cluster of these things. Most of them are just read-only replicas. We want to send write operations to the master database, and we don't have enough of those to worry about needing to scale them. So there's a few things going on with the request method here. And let's take a look at that. So I'm going to try and save you from my typing, but copy-pasting from PowerPoint is hit and miss. Here we go. So I'm going to post in a new season for 2019 in preparation for next year, and a link to the. Tell you what, before I do that, let's take a look at those seasons. No, now I screwed it. Boom. Okay, a lot of seasons. So what we're going to send in this guy is 2019 season, and it's linked to Wikipedia, assuming it's there. And yay, that worked. We got a 201 back with a location pointing at that location. So if I go seasons 2019, that's not the correct URL, is it? It's F1 seasons. Cool. So we can do useful things by looking at the request method. And we can also inspect the request body if necessary. So why inspect the request body? Ideally, we don't want to. API gateways, reverse proxy, REST APIs are designed so that everything you need to do to process those, apply policy, and proxy them should be available in the request header metadata. But as I said, not everything is JSON REST. Not, the real world is not always so beautifully aligned. Sometimes we've got some legacy routing requirements. Sometimes we actually have to look in the request body and have a look at something and decide what to do with it based on that. It's more of a XML SOAP problem than with JSON, than with REST, sorry, but sometimes that's true. And sometimes just your backend is flaky, right? So let's say that we've got a PHP monolith, and maybe this guy decided that he'd write his own JSON parser, and that it's not so good. In which case, we might want to validate that what we're actually sending in is indeed valid JSON. And that's also remarkably easy with the JavaScript module. We can look at the request body variable, which has got our request body in it, and send it to JSON.parse. And if we don't throw an exception, then we're good. And if we throw an exception, then clearly it's bad. And we can log that effect as well. It's not exactly that easy. So I said that we're looking at the request body variable. NGINX tries really hard not to populate that variable. And that's because it only wants to read the request body once it knows it's in a position to actually do something with it, only when it's ready to proxy. So we have to if we want to do this, which is why this is an if necessary situation, we need to trick NGINX into giving us into reading the body from the network. And we're going to do that by using the mirror directive. That creates a clone of the request, sends it somewhere else. We're actually going to send it nowhere, to somewhere just returns to 204 and ignore it. But the process of doing that gives us an in-memory copy of the request body. And that means that we can proxy pass to the validated variable, which was the output of the JavaScript function. So NGINX thinks it's about to proxy it. The variable gets evaluated. The request body is available. And we can check it. And we either proxy it to the back end as expected, or we proxy it to a 415 location, which says you sent bad media. All right, that's 10 tips for deploying NGINX as an API gateway. I hope it's given you something you can take back to your organization, so you too can be a hero with your API delivery, just like this guy. Before I wrap up, there are some resources on our website. We've just published this ebook for deploying NGINX as an API gateway. Lots of what you saw in this talk and the code snippets are in that ebook, and it links out to just for lots of config examples that you can take directly. Just search for API ebook on our website, nginx.com. That's it. Thank you.